We're going to start off today learning all about angles of a polygon, and today's theme is all about unicorns. Because we're using a graphic organizer, make sure you're paying close attention of where I'm writing, and make sure you're following along as I move forward. Okay, so the first thing you're going to do is you're going to write this question, what is a polygon? And you're going to put it right in this top section right here. You're actually going to be answering this question after I show you some examples and non-examples. So I'm going to keep my question out, get rid of this, and we'll put our examples on the left and our non-examples on the right. I'm going to take the time to draw them, and I'd like you to also in the space that's there. So here's one example of a polygon. Here's another example. It's kind of like a tooth. And here's another example. Here are some non-examples. Here's another non-example. And here's another non-example. Pay close attention to this side, right here. Okay, these are the non-examples and examples of what a polygon is and is not. What I'd like you to do right now is answer this question, what is a polygon, on that top line? And that's something I'll be looking for when I grade your notes. The next thing we're going to be doing is writing in this section right here. So I'm going to zoom in. And the first thing I'd like you to do is write down the titles of our columns. The first one will say convex polygons. Convex polygons. That'll go right here. And our second one will be concave polygons. Oh, polygons. There we go. Okay, we'll move that guy over. Now, some examples of a convex polygon. It's another picture. Could be like this. Here's another example. Here are some concave polygons. Here's how you can tell whether a polygon is convex or concave. And you might want to take a second and actually highlight the differences between here. Specifically, the word cave. That's how I remember. Concave polygons, if you connect one endpoint to the other, it creates a cave inside. That's how I know this is a concave polygon. Same as here, if I connected two endpoints, two vertices, I would create a cave. If I connect any of the endpoints here, any of the vertices, I don't create any empty space. That's the difference between a convex and concave polygon. So we're going to quickly go over the polygon names. If you already know them, you can fill them in and skip this section. We're going to find out the names for an n-sided figure, 3-sided, 4-sided, 5-sided, all the way to 10-sided figure. Starting with an n-sided figure is called an n-gon, like polygon without the poly. So if it had 20 sides, we would call it a 20-gon. If it has 3 sides, I really hope everyone wrote triangle, obviously. 3-sided polygon is a triangle. If it has 4 sides, we have specialized names like square and rectangle. But if we don't know what those properties are, the special properties of a 4-sided figure, we just call it a quadrilateral. A 5-sided figure is called a pentagon. A 6-sided figure is called a hexagon. 7-sided figure, heptagon. Notice how similar those are. Hexagon, heptagon. An 8-sided figure is an octagon. A 9-sided figure is a nonagon. And a 10-sided figure is a decagon. And that's all you needed to write in that section. Okay, so now we're in the bottom section of your notes. And we're going to start by writing in our Theorem 314, which goes as follows. It says the sum of the exterior angles, so that's the outside angles, of any convex polygon is 360 degrees. So Theorem 314 says the sum of the exterior angles of any convex polygon is 360 degrees. Now you have a little section below here that I would like you to draw a couple pictures of. Let's look at what an exterior angle really is. So imagine that you have a triangle. What I'm going to do now is I'm going to take that triangle and I'm going to extend each side out, kind of like I'm making a ninja star. The exterior angles are these angles that are on the outside. So you might want to draw an arrow that points to the exterior angles. Let's suppose you have a quadrilateral. Let's extend those sides out, extend sides out, extend the sides out, extend the side out. The little angles that are created, those are the exterior angles. So now let's focus in on the table, thinking about what we just learned in that theorem. The sum of the exterior angles of any convex polygon is 360 degrees. Now before we can really break into this, I want to make sure you know what one of the words is here. Right here where it says regular, I'd like you to highlight that. Regular is the same thing as saying all sides are equal. All sides and angles, actually. All sides and angles are equal. Make sure you know that that's what regular means. And now that you've made that note, I'm going to go ahead and erase it. Okay. Now let's talk about this guy in here. How many sides does a triangle have? How about a square? A pentagon? A hexagon? That's easy. But what about the exterior angles? How many exterior angles does one have? Let's look at a triangle. A triangle has 3 interior angles, but how many exterior angles? If I extend those sides and I count them, I would count 1, 2, 3 exterior angles. What if I had a square? If I have a square and I extend my sides out, let's count the interior first. 1, 2, 3, 4 interior angles. And what do you know? 1, 2, 3, 4 exterior angles. I hope you're noticing a pattern here. The number of sides is the same as the number of interior and exterior angles. So if it has 5 sides, it has 5 exterior angles. If it has 6 sides, it has 6 exterior angles. Now another easy thing to fill in is this last section, the sum of the exterior angles. That should be easy because, well, the sum of the exterior angles, according to that theorem, is 360. So I can go ahead and put in here 360, 360, 360, and 360. That's right. It said the sum of any polygon. These are 4 different polygons, and the sum of all their angles is 360, sum of their exterior angles. Where it gets interesting is if I ask for only one. That means instead of asking for all of the red angles, I'm only asking for one. So I want you to imagine in terms of this the square right here. If I wanted to find just one, and I knew that all 4 of them were 360 degrees. Since a square has 4 equal sides, 4 equal angles, it also has 4 equal exterior angles. So that means if I take 360 and I divide it between the 4 exterior angles that are there, my exterior angles will all be 90 degrees. For my triangle, I have the 360 degrees. Since it's equiangular and equilateral, that means that these outer angles are also the same. But now instead of sharing between 4, they're sharing between 3 angles. That means I've got 120 degrees for one angle. What I'd like you to do right now is I'd like you to pause the video and I'd like you to find the exterior angle measure of one angle for a regular pentagon and a regular hexagon. Go ahead and pause the video and then I'll tell you how much each is. Okay, so you should have paused. Hopefully you'll see now that what your answers are. The first one I'll show you is for a regular pentagon. A regular pentagon has 5 sides, so now you're going to take 360, divide by 5, you should have gotten 72 degrees. For a regular hexagon, you would have taken 360 degrees, and now divide by 6 exterior angles, that's 60 degrees. All right, you're going to go do some practice. Good job today.